Here's your 11.1.4 pre-calc lecture, part 2. So I was on problem 11-60, and I got down to letter C, and then I got stumped, and I also was running out of time. So letter C, it wants you to rewrite it in rectangular form, and it's got R equals 6 over 2 minus 3 cosine theta. And I was explaining where they got everything from, and it wasn't what I thought. So I'm going to do this one on paper right here. So what I'm going to do, this time I'm going to do cross product. So R equals 6 over 2 minus 3 cosine theta. I love cross products. So if I distribute my R, I get 2 times R, and negative 3R cosine theta equals 1 times 6 is 6. And then R cosine theta is equal to X. So I put that in. And then I went ahead and added the 3x on both sides and divided everything by 2 to get R by itself. And then I know that R is equal to square root of x squared plus y squared. And so this is the answer. So that was 11-60. Now let's read 11-70. I think we're going to be able to do that on Desmos, a lot of it, or 11-61. So let's read this, though. It says, have you ever wondered how you could rotate a parabola? You have seen parabolas open upward, downward, to the left, and to the right, but what about a parabola that's rotated 45 degrees? The focus of the next few problems is on rotating polar curves, and you will probably see this in your homework. While rotating a curve in the Cartesian coordinate system can be difficult, rotating polar curves is relatively simple. So on 11-61, it wants us to graph both of these on a graphing calculator. So hopefully I already have them on Desmos. Not there. Desmos. So there they are. So this one, this is called a limaçon. And so you've watched a video already, I think, in the last section about limaçons. So what are they asking us? 1 plus 2 sine theta. Yeah, they're saying, well, what do you think is going to happen to it when I replace theta with theta minus pi over 4? So let's look and see. So it looks like it got rotated counterclockwise by pi over 4. So that's cool, right? Just got moved over there. And then what else do we have? So, and then it also says, given the graph equals R cosine of 3 theta, and I think I remember this is going to be a rows. R cosine 3 theta, predict the graph of R cosine 3. Now we're replacing 3 theta, or replacing theta with theta plus pi over 3. So what do we think is going to happen here? Well, let's look. So it looks like the green graph got rotated by pi over 3 clockwise. So let me take it back off the screen. There we go. So when I put the theta minus pi over 4, it went counterclockwise. And then, but when I put a plus, it turned clockwise. Okay, so then it asks us, use this idea to write the equation of the curve formed when the graph r equals 4 sine 2 theta plus 2 sine cubed 4 theta is rotated counterclockwise by an angle of pi over 2. So counterclockwise, I think I want it to be minus pi over 2. So just plug in the minus pi over 2 in there, like replace theta with theta minus pi over 2. Okay, so, and that's true. So let's do the very last problem. What about rotating a parabola 45 degrees? Review your results from part B of 1159 and write the polar form of y equals x squared. Use this result. Did I do this one? 1159. Use this result and your observation from the previous problem to write polar equations for the graph that have been rotated clockwise 45 degrees. Test your results on a graphing calculator. So, parabola. Well, I guess I can do it right here. I had it all ready to go, but it's so y equals x squared. That's a parabola, right? Y is equal to r sine theta, and x is equal to cosine, or r cosine theta. Okay, so I'm just plugging in things that I know. Like I know that y and r sine theta are equal, and I know that x and r cosine theta are equal. And then I want to divide both sides by r. So that would give me sine theta is equal to r cosine squared theta, and then get r by itself, so divide both sides. And that's how they got the r equals, they got r equals sine. Instead of theta, I'm going to write theta minus or plus pi over 4. So this is where I would write, see, I'm just rewrote it like that. But instead of theta, I'm supposed to rotate clockwise by 45 degrees. And 45 degrees is pi over 4, so I go theta plus pi over 4. Okay. Sorry, I had it all written out, and then I don't know where I put it. And then you can test your results on a graphing calculator. So I hope you've all gone on to Desmos and graphed at least something in polar form since we started studying this stuff. And that's all I got for you.